Good evening, everyone, and welcome to the presentation of Istvan Nagy, who is from Debrecen, our very senior Java developer, and he brought a very interesting topic for today. Please feel free to ask any questions during the presentation in the chat window, because we are facilitating a Q&A session at the end of the presentation. The deck of Istvan will be available on the talks page after this session, and the recording will also be published on the social media channels of EPAM Hungary, such as Facebook and YouTube. Enjoy!
Thank you very much, Esther. Welcome, everyone. I hope you had a great time so far. I will try to continue this good series, and I will be talking about caching today. We will talk about many things, so I would suggest to dive right in. And as Esther mentioned, there will be an opportunity to ask questions, so I will try to answer. Okay, let's start with the definition. So caching essentially allows you to efficiently reuse previously retrieved or computed data according to the AWS caching overview. I find this definition pretty good because it grabs really the essence, meaning that we are all about efficiency. We want to reuse something that we already did and not waste any time or not pass on any opportunities. But let's talk about the types of caches that we can use or maintain. We have quite many. This is just 5 I grabbed. So we can talk about client-side caches, like the ones in your browser. We can talk about DNS caches. For example, all modern operating systems are implementing this, so it is used by everyone, we could say. Also, we can talk about server-side caches. For example, CDNs are utilizing this, or any web application server that is hosting HTML, for example, has or tend to have this opportunity. Also, we can talk about application level caches, and this will be the main focus of this talk as well, because this is the part when we are talking about changing your code and implementing something that will utilize the cache, and will cache certain results on your code path, and this is the thing that you can have the most impact on, I guess. Regarding the last item, database caching, this is with us for decades now. The database engineers figured this out fairly early, so they are particularly good at caching things. We can say that all of these have similar building blocks, but they are fairly unique on their own. Let's check what these building blocks are. So when we are talking about a cache, we can think of essentially a map. So key value pairs. We are storing certain values which are identified by a unique ID, a so-called key. And when we face the same request the next time, we can reuse this value using this key. We will touch base on this later. Also, we can talk about cache manager, which is basically this Spring terminology, but this is just a code which is managing your caches. So you can name your caches, for example, and this component will return the right cache based on the name you requested, and they will instantiate your cache, set up the config as you requested, and so on. Also, we can talk about the cache client, which is basically a very low level, like a bridge or abstraction that helps the cache manager and the cache to reach the underlying cache implementation. It can be, for example, Redis or Memcache, just to mention a few popular ones, but it can be as simple as a concurrent map in Java. So, it can be either very simple or something more complex. and this cache client, we are figuring out how to access it, because it is implemented similarly to a database driver when you are using JDBC or anything building on that technology. We can talk about the key. This is the same thing that I mentioned in the first list item. So the key is basically a short identifier that will be used to store and retrieve the cached value. There is something I need to mention here. So caching essentially tries to integrate into your flow, and your flow normally looks like having a request, then having a response, and caching can only deal with the data coming in. So in this case, the cache key must be created based on the request value. So it is usually a good idea to choose something as a key, and that is generally available in your request object. For example, a database primary key, those tend to be there, and they are unique, and they are fairly simple as well. So they tend to be really good cache keys. Also, we can talk about something that is called the origin service. This is basically the service that is being cached. So the original thing that would have been called if the cache would not be implemented or integrated at all. Basically, this is the source of truth, you can say. Also, we have a couple of cache operations. These are the things we can do with the cache in general, according to the abstraction we are dealing with. Let's talk about these a bit more in depth on the next slide. So as you can see, there is a nice diagram here, which tries to show a fairly complete flow. We are talking about a service that is shown in blue. It is calling an origin, but there is a caching abstraction or a caching layer in between with thread. So when we make the call, then we are on the cache level using a get call, which tries to retrieve something. If the data is there, then we are talking about a hit. In this case, it isn't, so it is a cache miss. And because we are dealing with a cache miss, we need to call the origin service. Then, based on the return value, we need to use a cache put if we want to find it the next time, because the put is essentially adding a key value pair into the cache. And when the put is completed, we can return as usual. So caching is really a middleman in this case. There is an opposite operation called evict, which is basically undoing the result of a put. So you can remove something from the cache based on the cache key. Also, depending on your low-level solution, it can happen that it implements a way for expiry. This means that you can tell it that please cache this for me, but only for 10 minutes or a day or an hour or whatever. So depending on your configuration, it will keep it there. Then when it expires, it will say that it is not found. So you need to put it there again. And just to mention the last one, we have a clear, which is kind of like a nuclear option for eviction. It is removing everything from the cache. And this is in general a bad thing if you need to do, because it can have an effect on your get success rate. Okay, talking about the goal, in general, we want to see more hits than misses. So we want to see the hit side a bit more than the miss side. And it should be fairly obvious because, just thinking about the timing aspect of these diagrams, you can see that in case of the get, everything happens in a lot shorter period. So by the half of the time, I would say, we are already done because the cache had the value. While on the other hand, we are dealing with origin call, we are doing all of the overhead, and we are returning. So it can have a huge impact on your performance. But performance is not all. So talking about more goals or more potential goals, just ticking the box next to performance we need to make sure that we still remember that caching has an overhead as well. And if you think about the red parts on the diagram so far, you can see why. So that represents some time being spent on caching only. And in case you have a miss, then that's not really time well spent. So another motivator that you can have for implementing caching can be reducing the load received by the origin service. This should be fairly obvious based on the diagram that is displayed right now, because as you can see, origin has no cause at all. So, it is just idle. If it was not even deployed, nobody would notice, as long as we are only seeing cache hits. Obviously, there are some challenges around this because evictions make everything tricky. So in case anything is missed, then a lack of an origin service would raise eyebrows, at least. Also, talking about the next motivation, you can think of reducing the impact of a failure in case origin is not really reliable for whatever reason. And it can be a valid one because, if we are not calling origin that frequently, then how unreliable origin is not really coming into the picture in many cases. So it's a good idea to reduce the dependency on an unreliable service based on this. But as well as it is combinable with the previous item, so the second and the third are fairly combinable. You should notice that relying on just the caching layer can be a problem, because when it dies, or someone goes clear, or something gets evicted, then we will fall back to the origin, and it can be a bad thing, because if origin is unreliable, then it can be even more unreliable if it is suddenly flooded with requests. Also, another motivation can be to save some cost, because if we are doing things twice or calling the same thing twice over the network, that's in general not a good idea, because everything costs money, especially if you are in the cloud. This can be valid because if we are using cache, then we are not doing all these, but caching costs money as well, especially if you are in the cloud. So you need to make note of this. So just thinking about when should you cache then? Well, there is a kind of a recipe that outlines the easy path, or when it is recommended to cache, or achievable, I would say. So in the first case, when your data is rarely written and often read, that can be a good opportunity, because it can ensure that you will have a lot of hits compared to misses. And the other idea might be when you are using a third-party API. These APIs tend to have some rate limits, and just to not run into those rate limits, your cache can help you to conserve some usage if you are able to reuse something. Also, if you are using certain resources, for example, you need to host stronger instances because of the CPU or network capability, and you have lots of memory just laying there, and you have a suitable use case, then you could implement some in-memory cache as well. So you would be just using resources that are already paid for, already there on your instances. You are just starting to utilize it better. So this might be one opportunity. We will see some drawbacks later. Also, if eviction events are well defined, that is a plus, because eviction is the evil of caching, I would say. And the last thing is kind of like a prerequisite. If you have no access to the implementation or the system or the stack, so if you have no way of changing the application, then most probably you won't be able to introduce caching either, unless you are using client-side caching, but then we are talking about caching on the application side from the other side, so your client, basically. Okay, so when is it hard? Well, I have collected a couple of examples which try to show tricky scenarios. In the first case, we decided to use in-memory caching in a cluster. So we have multiple instances, let's say n instances, and we have in-memory caches on all of them. In this case, the problem is that all of these instances need to, maintain their own cache. So we can be unlucky, and in case somebody is calling us with the same request n times, it can land on different instances every time. So it wouldn't come from the cache in any of those cases. So as you can see, this is not really the most efficient way of using caching. And also there is a huge drawback regarding the eviction, because eviction in this case is not really feasible, because you cannot really synchronize the cache contents if you are using just the in-memory cache on your instance. So an obvious conclusion can be to go for a cache cluster, and if you do, you won't regret it, most probably, because that is synchronizing everything for you. So it will take care of the eviction problem built in, because whenever any of the application instances say that please remove this item, it would remove for all of them. There is I would say, a special case of this, considering the eviction problem, when we are not really aware when we need to evict. Like, we are calling a third party, as I mentioned earlier, and we don't know when values changed unless we are making a new call. So in these cases, we don't know when to evict, so we are in the same situation. The only way forward that is fairly obvious is to use expiry. Cache clusters have expiry in general, but in this case, you need to make sure that you understand the consequences. So you are making a trade-off, because expiry means that for some period, the data will be outdated or might be outdated if it changed on the server side. So you need to make sure that your requirements allow this. Also, there is a very hard case where you cannot really do anything when data is written so often that the cache will be outdated every time you call. So in this case, you are paying all the overhead of caching and not using the benefits. So this is kind of pointless to cache, because you are taking a huge hit for no benefit at all. This is not recommended to cache. And there is a fourth case, which is a bit tricky, but I will try to show a few examples that will shed some light. This is basically the case when we have these bulk or batch APIs, when we try to reduce network overhead and overhead in general by grouping certain requests together into one request and getting the results with one call. So in this case, because of the problem that we need to create a cache key from the request IDs, we don't really benefit from caching, because it is not expected that all of the request parts would be reappearing. So if we are sending 10, 15 parts in one request, what is a guarantee to see the exact 10, 15 IDs in the same sequence the next time? So this makes it a bit tricky. Let's see the details. So we have one use case talking about the stock market. This is a hot topic nowadays. So there are certain pages where you can create a watch list, and you are just putting your stock quotes there, and you want to see the data, how they are doing from time to time. Usually these pages are not really concerned about showing the latest, most accurate data. They can use 5-15 minutes easily, even if they are caching the frequently changing data. But eviction is a problem because we cannot tell Wall Street to please ping us when something changed, and we don't really want to mess up expiry as either. But the different users have different tastes, so here comes the problem when we want to see the same stocks the next time. We will most probably need to fetch again. Our case is when you have like a popular blog or newspaper or video hosting platform, and you allow your users to comment under the content, and these comments can form threads. So each user can pin or follow or check different threads, and when they want to refresh, they would like to see them open. And because of this lazy loading nature and having multiple items in the list, it is not guaranteed that two users would want to see the same thing. Therefore, caching becomes tricky. Similar things can happen in GraphQL all the time if you want to utilize that technology. But the example I brought here is the YouTube API, which does this on REST. Yeah. So my point is that you need to understand your trade-offs. This is just an illustration, so you don't need to find any meaning in the illustration. But as you can see, we can easily think about 5 different categories that might benefit or suffer from using or not using caching, and we can have different impacts. It can be better or worse in all of these. So in my opinion, it is arguable that someone would sacrifice some performance due to larger cache overhead if performance is not the ultimate goal, and even some cost paid for caching in order to benefit from better reliability, for example, or reducing the cost of the provisioned instances, especially if maintainability is not suffering much. And especially with this mindset, and for the bulk and batch requests, I have decided to create CacheOnly, which is making this process a bit easier, hopefully. Let's see how it works. So CacheOnly is essentially a middleman, just like caching. And the diagram on the right side is quite telling. It is essentially the same what we did before, but it has some loops in it. So how does it work? First, we have a batch request with n number of parts. We are breaking that request into pieces, into partial requests. Then each part is checked from the cache in a loop, and if it has the data, then we are happy. If it doesn't, then we are just remembering that something was missed. And from the results from the cache, we collect everything that was missed or everything that needs to be fetched. We are merging it back together, calling the origin service, and then based on the results, we can split the response into parts, put the smaller partial responses into the cache. So the next partial request we'll match it, and then we will merge everything together. So everything that was coming from the cache and everything that was coming from origin is merged back together, and the service returns. So you can imagine that this might be quite some work, and you would be right. We have even some prerequisites. So you need to have a suitable use case, like a bulk call somewhere. You need to use Spring 4.2 at least. You need to use Java 8, probably not an issue because that's ancient and at this time. And you need either some existing caching implementation or integration, or you need to integrate it now. But once you have this, you just need to add the dependency. You need to implement 5 simple interfaces, and these interfaces are really simple. So you just need to wrap the service client, you need to configure the caching use case, you need to split and merge requests and responses and put everything together, then test it, and you are off to the races. So let's see this in a bit more detail. So as promised, the batch service wrapping is very simple. So the only mandatory method you have is this one on the left side. So you are talking about a single call that has a batch request type, which is generic. It has a generic batch response type, and it can throw an exception if anything bad happened inside. Regarding the cache config interface, this needs to return the cache name. This needs to return the partial response type for letting Spring to unbox everything and cost. It needs to be able to create a cache key based on the partial request, and this cache key is an own type, so it has 2 type parameters. One is for the cache, this C named one, and the I is basically an ID which identifies the partial request in the scope of the batch request. And obviously we need a cache manager somewhere. This is most probably just returning the bean that is already instantiated by Spring. So talking about the requests and responses, both sides are the same, just some words are changing. Once it is called request, the other time it is response, but the idea is the same really. So you have a batch that needs to be split into a map. The map has the I type IDs. This is the same I mentioned at the cache key. Then it has some partial requests or responses as values, and the merge method needs to be able to put it all together again. As there are some patterns that can be found. So in many generic cases, when you are implementing a bulk or batch API, you will use either a map or some collection-based solution, or you have a wrapper around a map or a collection. So these cases have pre-made implementations which are generic, and you need to just configure them with minimal hassle, hopefully, and you can use them. So what is the final piece? How will it all come together? There is one template, which is basically an interface that is already implemented by CacheOnly. It is just a big deal because it is generic and you need to understand which method does what. So let's talk about that. In one method, you can just access the things through the cache and call the origin service in the end. This is the top one, and the bottom one can be used to always call origin and put the results into the cache. This way you are refreshing your cache data. This can be used in a background processing thread, for example. So as I mentioned, this template is implemented already twice. One is a default implementation, which is just using one thread. The other is a concurrent one to get back some of the time, and make up for the loss. Both of them take care of partitioning automatically. So even if you call them with like 1,000 items in one request, and your origin can only handle 10, then they would split properly. Also, they are supporting different caching strategies, from use only cache or never cache at all, if you want to only utilize the splitting and merging functionality. Unfortunately, we don't have enough time to show any examples, but we have a wiki, so feel free to check it out. And to summarize everything we discussed so far, we have talked about the caching basics. We mentioned the goal of caching and what is easy and what isn't. We discussed a couple of trade-offs, and ultimately we discussed how CacheOnly is integrated and how it is working from very high level. I've put there a couple of links for you. So a link to the AWS caching overview, it's a quite good thing to read. And I have linked CacheOnly, the CacheOnly wiki, and you can find the jars on the Maven Central using this link. And with this, I thank you for your attention, and I think we can check the questions if there are any.
Exactly, Istvan. Thank you very much for this great presentation. And now I'm virtually turning to the audience. Are there any questions? Because I don't see any published in the chat window. And while waiting for your courage, I would like to tell you that we are still running some games online, and there's a quiz on the events page, so feel free to discover. And if you feel very well acquainted with EPAM and the IT history, you can fill the quiz and win some merchies. Okay. So any questions regarding the topic of Istvan? Okay, that must have been a very huge chunk of information, but I see no questions coming in. Okay, I just remember that there was a little technical delay on my side, and the first couple minutes of the presentation hasn't been shared. Could you please quickly jump back to the beginning and show the first few slides?
Yeah, sure. Just going back 1 second. Okay, so we started from here, and then we were talking about the definition. Then we went for the different cache types, and we progressed to the building blocks that were used during caching. I don't know how far do we need to go.
I think this was mainly when we jumped in, but if you guys have any comments, please put this info in the chat. But if I remember well, this was when I could pass it through. Okay, so I see no comments and questions. Thank you very much for this great presentation, Istvan. I really appreciate it, and I'm sure the participants as well. The recording is going to be available in the coming days, as I promised. And again, thank you for the participation to all of you.
Thank you all. Have a good night.
Good night.
Bye-bye.